First of all, we get into the lecture 3 requirements, and being able to learn those requirements is even more important. First of all, let's look at the introduction requirements. Why requirements matter, what requirements engineering is, what requirements come from, and what challenges are. So, why is it important to deal with requirements? So, the software requirements are the most important information in software development. The importance of requirements was recognized very early on, but this is not always reflected in practice. So the hardest single part of building a software system is deciding precisely what to build, like what is the requirement. No other part of the conceptual work is as difficult as establishing the detailed technical requirements. No other part of the work so cripples the resulting system. If done wrong, no other part is as difficult to rectify later on. This is from Fred Brooks, 1987. We know that requirements are unclear, the wrong product may be built. So errors here cripple the resulting system and are hardest to rectify later. This is why requirements need to be clear. If they're unclear, then we have the wrong product, and then when the wrong product is built, then you cannot do anything to roll back because you just didn't know what to build. So what is requirements engineering? Requirements engineering is a systematic, disciplined, and quantifiable process for the determination, analysis, specification, and management requirements, with a goal to understand the wishes and needs of stakeholders and users, of course, and minimize the risk of delivering a product that does not meet these wishes and needs. So, if you deliver a product that does not meet any of this, then this is a problem. Then we have which subdisciplines activities are involved in requirements engineering. Requirements elucidation, for example, extracting. These are the disciplines involved in requirements engineering where we elucidate requirements, extract requirements. This is number one, where we extract requirements. And these are from requirements engineering. What does customer user need, want, collecting functional and non-functional requirements through interviews, user discussions, market observations, design thinking workshop, etc. Then we have requirements analysis, design validation, classification, evaluation, prioritization, comparing and testing according to cost and benefit aspects, consistency and completeness. We check these things. This is validation, it's requirements analysis. It's also requirement validation is requirements analysis. Verification is requirements elucidation. It's extracting requirements. It's functional and non-functional, the same thing. Then we have this according to cost benefit aspect. We have consistency, we have completeness through prototyping and iterative testing. There are different ways we test. We do comparisons, we look at completeness and etc. This is more of the design, that is it is it usable, does it work. Then we have requirements description in a standardized form, naturally linguistic sentence, tense, models and prototypes, etc. For example, requirements management, re-examination, modification of system. We know that house building, elucidation would be the architect surveys and determines the wishes, requirements of the client. This is also verification, like knowing the requirements. Okay, we elucidate. For the first step, we elucidate the requirements, we take their wishes. Then we analysis, the architect classifies, evaluates priorities together with client, perform cost benefit analysis, creates models, prototypes, for example, and specification. The architect documents the requirements, plans, decisions, management dealing with requirements over the course of the construction project. Some requirements are discarded, for example, they're too expensive. Some are added if ground conditions require a certain construction method. So requirements engineering is not an end in itself. Its result determine the quality and efficiency of the project and required in further process and are the key to the customer satisfaction. So requirements engineering, it's not finished itself. Its result determine the quality and efficiency of the product. Basically, it becomes pretty much clear why. Then we know that what is a requirement? A requirement solves a real problem or fulfills a real world user need. It's based on user need. So requirement is a wish is what, for example. Requirements a condition or capability needed for a user to solve a problem or achieve an objective. A condition or capability that must be met or possessed by a system or system component to satisfy a contract, standard, specification, or other formally imposed documents. A documented representation of condition. Be able to name all three parts: user conditions capability, system condition capability, satisfy a formal document, and documented representation of either. So of course you can either have a user wish, user condition, or you can have system condition, system capability, system based requirement, or you can have a documented representation of either one of these. Then where do requirements come from? They come from project-based software engineering. A problem a customer generates requirements customer rarely manufactures, which are implemented as software manufacture that solves the problem. So there are project-based software engineering and there are product-based. In project-based, we have a customer that generates requirements and customer rarely manufactures, which are implemented as software manufacture that solves a problem. And product base is a need, an idea. A user inspires requirements manufacturer which are implemented as features of the software manufacturer. The need is realized, fulfilled. So we have a project base where we have an idea, we have a need already, and then this inspires new requirements and then which are implemented as features now. So or in this way we have a project. So a problem, a customer generates requirements and then we have implemented. So then so this is for a customer already having their requirements ready. So they have requirements, they say okay, we have a project, we have these requirements, please implement them. Then in product base, he just have an idea that inspired the so it's from scratch. We have an idea from scratch, we generate something and then implement them as features. So motivation for further development is business and customer needs, dissatisfaction with existing solution, technical changes. What are the sources of requirements? System context, stakeholders, systems, documents. These are the four sources of requirements from where we can get the requirements. Stakeholders are customers, users, but also operations, development. These are basically anyone. Stakeholders are human beings. Any human being can are stakeholders. So and system is legacy system, competition, etc. Competitive. What are the challenges in dealing with requirements? Then we know that we have challenges like unclear objectives. We don't know objectives, high complexity of the task to be solved, communication problems, loss of knowledge over time, poor quality of requirements, consistently changing goals and requirements, etc. Then we have elucidation and classification, current state versus target state, elucidation methods, etc. Then we know that so it says that if I had asked people what they wanted, they would have said faster horses. So why should the analysis of the current state not be skipped? In order to be able to describe requirements for software well, an analysis of the current state is necessary. Example, an understanding of current working environment of the users. We call the working environment the context. As far as possible, this should be independent of the consideration regarding the new software so that the focus is not immediately on technical solution. Based on this, the analysis of the wanted state is carried out. So we look at the current state, how do we stand now, and then what is the target. Not that we just start doing technical work. We first get ourselves comfortable with the environment, what's now, and then we do analysis of the target state, the wishes for the new software, and determine the requirements are specified. This is also called actual survey or target survey. What difficulties arise when asking customers about their wishes? We have continuity versus change. So users focus on what they currently don't like. Implicitly, customer users expect that everything that has worked or was good so far will stay that way or get better. The requirements for the new system therefore only contains a very small extent of request for change. The vast majority of requirements are for continuity. So what we need to know is that creating an understanding of the user's environment, what do they see, hear, do, collect all their wishes, pain points, pains and gains. Do not criticize for the time being. Wish list. Disclose, like for example, wish list is the things that they might. So disclose contradictions objectively. Discuss alternatives. That okay, this is alternative. Most people are not even aware of them. So we need to discuss the alternatives if in case. Further difficulties are too many requirements, unrealistic requirements. A customer has requirements that he does not want to say. Customer has requirements that are so evident that she does not say them. Customer has requirements which he cannot formulate. Knows the problem but cannot derive the requirement. Which methods of requirements elicitation exist and which suit current versus target state. Elicitation of existing data, documents and system archaeology is current state. Observation is also in current state. Surveys, it's also in current state, it's also in target state. So creativity techniques, mind mapping, headstand, 635 method, etc. is not in current state, it's only in target state. Prototyping experiments, it's only in target state. Design thinking, it's only in target state. So the processes run along a spectrum towards co-creation. Bottom to list check marks in parentheses are applicable with restrictions. So there are restrictions here, of course. Observation and existing of evaluating data, but here it's the same. We target state, we do the same, we do survey and all of this. Then we might look into know which methods work for both. Analysis, survey versus mainly target state design thinking. So there are some methods that work for both, like these, current state and target state. And then this as well, survey for example. So no method work for both. Survey analysis analyzes survey versus mainly target state. And the document evaluation and this are evaluation of existing document system archaeology is for the same for both. Observation works for both current state and target state. Surveys work for both current and target state. Then we only have for target state. Creativity, prototyping, design thinking. Then what characteristics system archaeology document and analysis. Asynchronous method, independent of the availability of stakeholders, increases the chances of not forgetting any requirements from the old system, can be very time consuming and depend on the quality of the documents. Reuse and further development are based on result of system archaeology, must be combined with other techniques to ensure the document is up to date. Which forms of observations exist? So first observation is stakeholders exist, are monitored when using the IST, the current system in the system context at work, with or without a system, to record work processes, time dependencies, etc. Apprenticing, like live, like field observation, but we have interruptions are allowed for interim question from the requirements engineer. So we have apprenticing, these are forms of observation. So like field observation, but interruptions are allowed. You can interrupt the person, questions from the requirements engineer. So it's a field observation, are monitored when using current system in the system context at work, without, to record work progress and time dependencies. So they're not interrupted, it's something that you just observe. Then we have, this is, you can interrupt the person. Then you have contextual inquiry, the requirements engineer learns, executes the activities of the user in order to derive requirements for new change systems. So we know that we learn, requirements engineer is learning this, and then he's able to do that. Now what are the tips for good interviews and which questionings exist? Prepare for interview. First of all, open versus closed questions. Active listening, absorbing and repeating information, this is active listening. Record everything, note taker should not be interviewer at the same time. Of course you should be note taker should not be the interviewer at the same time. So someone else is a note taker and you are the interviewer. Post process the interviews. Clean up the notes promptly while the knowledge experience is still fresh. Then we have questioning techniques. Deep drilling. Can you describe this in more detail? Which aspects are important to you? What else is involved? So could you describe the situation as follows? Did I understand you correctly when I said? Synthesis. Let me summarize once again. In your opinion, the most important points are 1, 2, 3. This is synthesis. So these are questioning techniques. Then we have filter. Separate the important from the unimportant. What is more important, A or B? How often does case X occur? This many times. Parking. Then we have, if unclear, clarify the parked issue and further procedure afterwards. These are different questioning techniques. For example, just like we mentioned, this is the deep drilling. Number 1, deep drilling. Number 2, active listening. Number 3, synthesis. Number 4, filtering. Filtering what's wrong with what's right. Number 5, parking. Then what are the advantages and disadvantages of questionnaires? Advantages is that high number of stakeholders can be surveyed efficiently. This is advantage, time and location independent form. Easy to evaluate, of course. Then we have difficulties, that implicit knowledge difficult to determine. We have follow-up questions. Further questions are difficult. Suggestion is that the questionnaire can offer a good alternative as a basis for further methods. How can requirements be classified? We have functional requirements and we have non-functional requirements. Then we have open versus latent requirements. Then we have must versus can requirements. These are different kinds of requirements that are classified. So what are non-functional requirements and which categories exist? Functional requirements describe what a requirement must implement. Non-functional requirements describe how well a service must be fulfilled, how well it should be fulfilled. These are non-functional requirements. These are more quality related. Then can increase production cost over time, many times over. Can be demanded, validated and documented just as systematically as functional requirements. Sometimes they also refer to as quality requirements. Non-functional requirements, categories of non-functional requirements are requirements for the user interface, quality requirements, requirements for the technology, legal and contractual requirements, requirements for other delivery components, requirements for activities to be carried out. But we know that functional is what the system does. Non-functional is how well it does. Be ready with the example for each 6 of these categories. So what it does, and then we have categories of non-functional requirements. 1, 2, 3, 4, 5, 6. So requirements for user interface, this is for non-functional, right? It's just the user, how the UI will look like. It doesn't really matter. It's non-functional. Quality requirements. Then we have requirements for technology. We have legal and contractual, etc., etc. Then we have what are quality requirements and what are the Ludwig characteristics of usability. Then we know that a quality requirement includes specifications for the quality of the product or processes, requirements for quality of use, product quality, data quality, etc. There are different standards for describing individual quality features. Company specific specifications are necessary. So we have characteristics of usability. Each is high if correctness is high if the specification is correct and the rest of the software is correct in relation to the specification. Reliability is high if the software rarely fails to perform the expected function. Accuracy is high if the result deviate only slightly from the mathematically correct result. Efficiency is high if the software requires hardly any more computing time than the minimum required. Fragility is high if the software requires hardly any more software space and other resources than would be minimally required. Performance completeness is high if the software actually provides all the required services. Manual completeness is high if the manuals provide exhaustive information on all useful user questions. Consistency is high if the software behaves similarly towards the user in similar situations. This applies to operation, error messages, data formats, etc. Then comprehensibility is high if the user quickly understands how to use a software. Simplicity is high if the software appears conceptually simple to the user. Then we have what are the Ludwig maintainability characteristics. Each is high if it is for maintainability. Specification completeness is high if the specification fully states the actual requirements and only states these completely. Locality of software is high if the remote effect of the software effects beyond the boundaries of the software components are avoided. Testability of software is high if the program can be executed under defined conditions and the relevant result can be recorded in full. The execution is therefore reproducible. Structuredness. The software is divided into logically contained units with high cohesion and low coupling. So structuredness is high if the software is divided into logically self-contained units and high cohesion and low coupling is there. It's not coupled closely together, it's distinct, and within one module it's high cohesion, it's tightly packed. Then simplicity is that the software only contains a few designs that are difficult to understand. So simplicity is high if that the software only contains a few designs that are difficult to understand. Scarcity of a software is high if its scope has been kept low by avoiding redundancy of any kind. Readability of the software is high if a foreign reader is able to grasp the content correctly with minimal effort. Device independence is high if the features of special devices play a minor role in it. Seclusion is high if the software provides a well-defined service and therefore has hardly any interface to other system. Structuredness is equal to high cohesion and low coupling. This rephrase appears in design lectures as well. Then we know that what are requirements for what is structuredness, how to make sure that we have structure. Structuredness happens when we have high cohesion and low coupling. What are requirements for delivery components? All products to be supplied that serve the development, operation, and use of system. Development artifacts, for example, prototypes, test documentation. Operating artifacts, operating manual, safety concept, hardware documentation. Then we have application artifact, user manual, online tutorials. Then we have installation tools. What are the other non-functional requirements categories? Legal, activities, technology, UI. Legal and contractual requirements. Contractual requirements, maintenance contracts, requirements for the subcontractor only after approval by the client. Offer and costs. Legal requirements and compliance. Requirements for activities to be carried out. Activities, development activities or activities for and operation of the product. Product development activities, example, running reviews, quality management, and activities during the product life cycle, example, installation, maintenance, etc. Then we have, these are the other non-functional requirements categories. Then we have technology requirements, restrict the solution space for implementation, specifying solution properties of the system or its interfaces or its operating system environment. Then we have requirements for user interface, specification regarding the user interface, optics, acoustics, haptics. This is for user interface, of course. You can see this is for our user interface and operation of the system. Example, design dialogue, guidance, personalization, internationalization, accessibility, etc. This is the requirements for user interface. What is the difference between must and can requirements? Must, mandatory requirements, acceptance of the system can be refused if a mandatory requirement is not fulfilled. Can, optional requirement that increase stakeholder satisfaction when fulfilled. This classification is legally binding. For example, must is a must, can is optional, but it increases satisfaction when fulfilled. What is the difference between open and latent requirement? Open requirements formulated by customer user, known and they're explicit. Latent are unconscious for unformulated requirements, unknown or unconscious or implicit. Reason for latent requirements are assumed and are not explicitly stated, or they are not known. Must versus can and open versus latent are independent dimensions. A latent requirement can still be a must. So, example, a self-evident safety expectation. So it is still latent, but still it is a must, so we need to take care of it. So we have context analysis level of abstraction here. Now we're going to talk about in part 3, where we will have views of system, and we will talk about the context level methods, user stories, dictionary of terms, quantity structure, roles, and personas. Now, why is it important to understand the context of use? Because we develop software for users, that's why it's important to understand what needs and challenges need to be solved. Never start building software without understanding for whom and what problem is to be solved or what needs to be fulfilled. So what level of abstraction of a system exists? There are different level of abstraction and views of a system, and different methods for different levels of abstraction and views, for coarse granular to fine granular. We have context level, the context of use, who uses users, what challenges do they face, the requirements for a house of a family of 5, and different from those for our apartment of for a retired couple. So domain level, the area of application, housing, building, banking, gaming, e-mobile, etc. Here is important to understand what makes the domain tick, what vocabulary is important, what rules there are, etc. For example, shopping and banking. Then we have interaction level, the way in which the system is interacted with, what interaction patterns are there, speech recognition, mouse input, etc., interaction with the system. Then we have system level, what features and system functions the system should have, which user requirements are mapped to which user functions. We read cards, we authenticate, we carry out transaction, we cancel, system modeling. Then we have order plus granularity, gives us context. Domain gives us interaction gives us system. From coarse granular to fine granular, requirements exist at all of these level of abstraction, at system level, at interaction level, at domain level, at context level. All of this have requirements to them. Then we have which different views of a system exist. According to Gorman 2021, discovered to deliver agile product planning and analysis with the ATM example from the lecture. We have user, shows card, interaction, interface, authentication. We have procedure, transaction. We have data, bank details, customer account details, etc. We have non-functional requirements, secure, usable, performant. We have surroundings, the platform, etc. We have constraints, restrictions, 3 times invalid pin possible, etc. Then we have which contents and methods belong to the context level. Then we have contents at the level at the context level, and their meaning and their methods for modeling and specification. For example, we have vision, we have product vision, board treated in product management. We have goals, example smart treated in project management. We have tasks, we have user stories, we have tasks, templates, we have scenarios, dictionary of terms, quality structure. We have roles, these are personas. Then dictionary of terms is created from the outsets and refined and supplemented as the product cycle processes. What are user stories and how they are formulated? User stories describe desired functionalities or properties of a system from the perspective of the person who needs the functionality or property. The function or feature has added value for the person. Then we just look into that. What are user stories and how they're formulated? User stories describe desired functionalities or properties of a system from the perspective of the person who needs to fulfill the functionality or property. The function of or feature has added value for the person. A typical template for formulating good user story is a role, who, I would like to, goal, wish, what, to be, benefit, added value, why. Example, as a resident, who, I would like keyless access to the building, what, to be able to enter the building with my hands full, why. Formulate user stories independently of the solution. And in that way, we would know that as a resident, who, I would like to keyless access to the building, what, to be able to enter the building with my hands full, why. Then we know formulate user stories independently of the solution. As a customer in the store, I simply want to pay for my purchases to be able to take the goods. Solution is not provided here. As a customer in the store, I would like to withdraw money to be able to take the things, take the take the goods. Solution is given. Solution space extremely limited. So you never give solution in your user stories. You never do that. Who, what, why, and solution independence are two different things. Checked when you must write or critique a user story. So solution is not provided. This is perfect. Solution space extremely limited. You don't do this because solution is given. User stories never have solutions. Why should a dictionary of terms glossary be maintained, and what does it contain? To create a glossary of terms right from the start and continue to develop the document. It helps to keep your bearings in the jungle of terms. Uzmo. The main problem in requirements engineering are communication problems. Even if you think you have understood everything, you may be in for a nasty surprise. The dictionary of terms contains terms that are important and could be interpreted differently by different people. Often terms that appear to be completely clear at first glance and in entries contain terms and synonyms as defined in a specification. Then we have abbreviation, then we have origin, conversation, document, etc. Then we have meaning, definition, explanation. Then we have scope, where is this term not applicable. Then we have validity, temporal, spiral, other. Then we have questions of designation and ambiguity, etc. Then we have uncertainties that have not yet been resolved. Then we have related terms, cross references. Now what is quantity structure? Then we have what is a quantity structure. Information on the problem size should be an integral part of the specification. Then we know that information on the problem side should be an integral part of the specification. All specifications define the upper limit, lower limit, or typical values of significance. For example, length of the pin, number of transaction per time unit, range of change of certain states, etc. What are roles and personas? Roles and personas describe actors of the current and or target state. Then we have roles describe user groups, personas describe specific representatives of a user group, and we have personas contain all information that is important to understand user in order to be able to put yourself in the shoes. Different templates exist, all have the following categories of information in common. For example, we have personalization, we have personal data of the individual including picture, occupational factors, details of the individual living environment. We have relevance, details about the interest in the product. We have education, details on education and experience. Then we have part 4 that is related to requirement specification, functional specification, documentation, Lastenheft versus Pflichtenheft, document structure and level of detail. What is document generally important? Why is document generally important? Direct communication is extremely important, but there are some good reasons why documentation is important. Writing down forces us to formulate certain things precisely. Common understanding not only in the heads. Documentation is particularly important for longevity of the content, legal relevance, complexity of the content, accessibility for many stakeholders. Documentation also serves as a means of communication, of course. Then we have what are the benefits of the specification in software engineering processes. Brings us to our next question, that what are the benefits of the specification in the software engineering process? We know that the specification is the basis for various activities in the software development process. For example, coordination with the customer and marketing, the design and implementation, the user manual, the test preparation, the acceptance, and the reuse. Then we have the clarification of later objects, recourse claims, etc., and a later implementation. Then we know that there is no specification in the head. A favorite quotable line for this question is this, that what is the benefits of specification in software engineering process? Then we need to know that what belongs in a technical document. In a technical document, we have introduction, we have purpose, who created the document and how, who should read this document, who is bounded by this document, scope of use. Then we have in the technical document summary, scope and share stakeholders. Then we have 1.3 definition and abbreviations, definitions of terms and abbreviations including the glossary. Then we have 1.4 references, standards and rules, list of reference documents. Then we have overview, content and structure of this document. Then we have core content, then we have summary, and then we have appendix.
and index, including the table of contents. Then we know what is a requirements specification. German is Lastenheft. What is a Lastenheft requirement specification? So functional and non-functional requirements that the system to be developed must or can fulfill. Also requirements, delivery conditions and acceptance criteria that are relevant for the subsequent acceptance of the system, particularly relevant for tenders and when drafting contracts. The basis for tendering and contract design in a formal classic project setting. Lastenheft also is compilation of all the client's requirements with regard to the scope of delivery and services. The requirements specification contains the requirements from the user point of view, including all environmental and boundary conditions. These should be quantifiable and verifiable. The specifications define what to be solved and why. The specifications are drawn up by or on behalf of the client. It serves as the basis for tenders, offers, and or contracts. Then we have Lastenheft, the entity of the requirements specified by the client for the deliveries and services of a contractor within an order. Then we have functional specification, Pflichtenheft. Implementation, functional specification, implementation specifications drawn up by the contractor based on the implementation of the requirement specification provided by the client. This is functional specification description of the implementation of all requirements of the requirement specification. The functional specification contains the requirement specification, user specification are detailed, and the implementation requirements are described. The functional defines how and with what. So this is how with what, and that was what to be solved and why. What and why is Lastenheft. You can easily remember it by this, that what and why is Lastenheft. How and with what is Pflichtenheft. This is more about my side. So, and that is the side of the person who will give the requirements, the customer. The requirements are to be implemented as a rule. The functional specification. So Pflichtenheft also known as functional specification, and Lastenheft known as requirement specification. So then we know that functional specification is drawn up by contractor after the order has been placed. If necessary, with the cooperation of the client when drawing up the functional specification, the contractor checks the requirements specified in requirement specification are consistent and can be implemented. They're consistent and can be implemented. So Lastenheft, we know what and why, drawn by or for the client, basis for tenders and contracts. Pflichtenheft, how and with what, draws up by the contractor after the order contains the Lastenheft. This contrast is a classic question. Then we know that how are requirement specification and functional specification combined in practice. Combining both is a pragmatic approach to avoid inconsistencies between two redundant documents. Different scenarios can be found in practice depending on how formal a project is set up and how agile the development is. Spectrum from high formalization classic project management rather than product-based software engineering down to a low formalization agile project management, rather product-based software engineering. So rather rare, requirements and functional specification are managed in parallel. In the initialization phase, the requirement specification serves as the basis for tenders and contractual arrangements. Later, agreement on a joint document, typically requirements application. A joint document is created and further developed from the outset. The client is the product owner and the responsible for creating and maintaining the documents and the backlog. So scenario from the lecture is, while creating the functional specification, we find out the project will be at least 3 times more expensive than initially expected. The Pflichtenheft phase is where the contractor checks that the Lastenheft requirements are consistent and can be implemented. So this exactly where such findings surface and must be renegotiated with the client, scope, budget, or requirements. Then what does an example specification structure look like? So it contains description of the product content, context, purpose of the product, product vision, for example, business goals to be achieved, users and target audience, roles and persona. Then we have processes in context. We have current status, task description in which the product is required, including task roles. We have target state, task roles, user stories. Then we have system requirements, overview of the system, coarse granular summary of the system, example in a use case diagram. Then we have functional requirements, processes, and behavioral description like user stories, use cases, system functions, and data specification, UI structure. These are all part of functional requirements depending on the context, behavior, and structural diagrams. Then we have non-functional requirements as 3.3. So this is also an example of specification structure. Then we have project requirements. Then we have overview of procedure and processes, assumption and dependencies, and acceptance. For example, templates is V model XT structure, last and half, Licht and half. And then we have what determines how detailed a document should be. Scope and level of detail of a document depend on the risk that would result from the required information not being written down and unable to be found. It also depends on how often and how many readers need the information to clarify questions. And the more people need a piece of information, or the more often a piece of information is needed, the more important it is to write it down. So high risk of errors occurring due to missing or misleading information, high probability of change. Then we have quality requirements. What are the criteria of good requirement documents? Complete, all relevant requirements are fully documented, including errors, exception, formal completeness, for example, graphics, tables, list of sources and abbreviation, etc. We have consistent, free contractions, consistent terminologies. We have realizable, on time and within budget. We have validatable, we can check that needs are met. Understandable for the readers of the document depending on the target audience. A document may or may not be comprehensive. Stakeholders, correct, necessary, appropriate. Is my order task accurately reflected? Am I getting what I asked for? Developers, are the requirements feasible? Tester, are the requirements testable? Can test cases be derived? Project manager, are requirements feasible? What is the language problem of fuzzy requirements? Natural language is ambiguous. Seemingly clear statements hide unstated cases. For example, so you open the lock at the main entrance in the morning. Yes, I told you every morning. Of course. Even at the weekend. No, the entrance is closed at weekends. And during the company vacations, of course, it stays closed. And if you are ill or on vacation, then Mr. X does it. And if Mr. X also drops out, then at some point a customer knocks on the window because he can't get in. What does morning mean? So you get to know that it's so ambiguous, because then we kept asking and then we got to know that it's not that you open the lock at morning entrance in the morning. Every morning is not a meaning. So the point is that every unquestioned word morning hides special cases. Requirements must be made linguistically precise by systematically probing exceptions. Then we have use cases. What is a use case? German Anwendungsfall. A use case specifies a function of the system that provides a business value for at least one actor from the system context. Actors are people in a specific role and neighboring systems that interact with the system when the use case is executed. Then we have the system is a black box. Only the externally visible behavior is described. Use cases are completely system processes. Then we have where do use cases come from? Use cases are derived from context analysis, which tasks or user story should be supported by a system, which system function does the system use to support the respective steps. Is there already a system function that supports the step? Does this need to be added? Which system functions require the data you identified in the context analysis? Use cases diagram can detail user stories and relate them to each other. Use cases are described both graphically and textually. Then we have which notation elements does a use case diagram have? Then we know system boundary refers to restaurant example. We have system boundary refers to a system that contains the defined use cases that interact with the user. Rectangle labeled, for example, my restaurant. These are system boundaries. These are contains interact with the user. We have actor, model a type of a role that an external user or an external system assumes during interaction with the system. So this actor will interact with the system that we made. Restaurant. Then we know that human actors as stick figures, guest systems with. So we say systems. We will say, okay, human actors are stick figures, guest systems with the stereotype actor like this, and then saying actor next to it. Actor. This is a system. If a system interacts with another system, payment system, then use cases specifies a closed set of actions that are provided by a system and bring a recognizable benefit or one or more actors, and ellipse order meal, for example, inside the system boundary. So we have in a restaurant order meal. So he wants to order a meal. Inside the boundary, alternating modeling with a use case stereotype. So it's alternative modeling is rather rare. So this is the same way. Association models are a relationship across actors and use cases. Association can be non-directional and directional and contain cardinalities, for example 0 to many or 1 to exactly 1. Then we have 2 to 5 directional, example only one guest can trigger one meal, only one guest can trigger one meal. The waiter is involved in use case but cannot initiate it himself. Generalization, specialization, it describes an inheritance relationship between actors or between use cases. Service manager specializes waiter, pay by card, specializes pay invoice. So we have these specific generalizations, inheritances. What is the differences between include and extends relationship? Include is must relationship, model that a certain functionality is and must be included in the use case. Pay invoice or authenticate user or include relationships are suitable for modeling the reuse of substeps that can be integrated into several use cases. Basically a subfunction call that it includes. It's a must. Include, you can write this and then you are able to do it. Then we have extends. Can relationship models the conditional integration of the functionality of one use case into another use case. It has an extension condition and an extension point. Example, I issue a voucher, extends order meal. Then you have condition guest. It's a can, it's an optional. You can issue a voucher if you want, if not that's dependent. It's not a must. Extend relationship also allows partial functionality to be outsourced. The extending use case can typically also exist without the caller, avoid cyclic dependencies. Then we know allow direction, arrow direction matters. So include points from the base use case to the individual one. From the way includes that, like this. And extends points from the extension to the base. So extend this extends to this. So extends goes like this to the person. And then include is always, it's a must. Extend is a can condition. How is the use case described textually? So we know that typically as a dialogue between system and user, the main scenario is the happy path template with the lecture. So we have happy path name, we have unlock door with manual intervention. This use case describes the entire process from identification of an authorized person to unlocking a door. We have actors, person, outward facing. Precondition, the outward facing door is closed and locked. Trigger, the person wants to unlock the door, enter the house. So a person arrives in the front door house. The system detects the person as authorized. The system saves the result. The system unlocks the door. The authorized person opened the door. Use case is completed. Then we have alternative scenarios. Then we have post conditions. What is the procedure for creating use cases? We first identify actors, peoples, and systems. This is the use case diagram. The task analysis provides important information for the steps. If system interacts with system to be modeled, they are also actors. Set system boundaries. The system boundaries define what belongs to the system and what does not. Identify use cases of the main functions. The use case of the identified main functions are roughly formulated. It must be ensured that the use cases fully cover the functionality. Then structure use cases and the actors. The relationship between actors and use cases as well as between the use cases themselves includes and extends are identified. Then outline the normal sequence of use case. The normal process, the path to the desired goal of the main actor should be formulated first. Then describe special cases and alternative processes. It must be clarified which special cases and which alternative processes can occur and how these deviate from the normal processes. Check for and extract identical interaction sequences. Identical interaction sequences can be defined as basic functions and used in several places. With the help of generalization relationship, sequences can be specified generically, then specialized and reused. Then validate use cases. The use cases are checked in reviews and released once all corrections and improvements have been incorporated. So these are the different steps you can go about when you're making use case diagrams. What must the project requirements specification contain? Project task, readiness for acceptance. So this is a project requirement specification. Part of readiness for acceptance is a requirement specification with the following contents. We have product vision and product goals. We have roles and personas. We have user stories. We have glossary of terms. We have quality structure. We have use cases. And that was it about the lecture number 3.